All right, so the performance task that we're about to do outside, let's talk about this, okay? So it says, let's say Gomez. Gomez wants to determine the height of the tree in front of his house. He stands 42 feet away from the tree. So here is this beautiful tree, if you will. That's an ugly tree. And his line of sight is 5 feet from the ground. So he uses the compass app on his phone to determine the angle of elevation to the top of the tree. So if I'm looking at this, and I'm looking at angle of elevation, and it's 43 degrees, where am I going to put that? Where am I going to put 43 degrees? I'm going to put it right here, right? Oh, 43 degrees. Okay? And we want to know how tall the tree is. You with me? There's one thing that I haven't yet written that some of you are looking at this problem so far like, something's missing. What's the thing that I haven't accounted for?
5 feet.
The fact that what? The 5 feet from the ground. Yeah, the 5 feet from the ground, that means my eyeballs right here is 5 feet. So the line of sight where I have my eyeball from here down to the ground is 5 feet. Are you with me? So if that's the case and I'm doing this, I could still look at this triangle and solve it like normal, right? I could look at it and solve it as normal. But what will I have to do when I get this height of what I think the tree is? What will I have to do to that? I have to add the 5 because it's accounting for, guys, it's from my eyeball to the top is the height. But we have to add the additional 5 feet in order to get the true height of this entire tree that is going to be from the ground, of course, all the way up. A little pretty. All right, cool? Are we good? So let's go ahead and solve this triangle that we set up from our compass and whatnot, okay? So if I have a triangle of 43 degrees elevation, 42 feet, you tell me what letter of adjacent, hypotenuse, or opposite does 42 represent? Adjacent, yeah, nicely done. Here's my angle theta, and here's A. What letter do we want to find? The height. So we want to know, what was the letter that we used? O for opposite, yeah. So I have something that I'm going to use SOHCAHTOA with, and obviously which of those 3 trigonometric functions will I end up using? Tangent. I'm going to use tangent because it's talking about the opposite over the adjacent. So tangent of theta. Our angle that we have is 43 degrees, and the opposite is unknown, and the adjacent is 42. Okay? What would y'all do to solve for x? Anybody?
Put it in the calculator with the solve feature.
Perfect. You can put in the calculator with the solve feature. In solve or regular solve, does it make a difference? Does it matter? What do you think?
Just the regular solve.
Just the regular solve, because it's not a what that you're looking for?
An
Angle. Nicely done. So solve, we're going to solve feature this of tangent of 43 degrees inside is equal to x over 42, and we're going to comma, what do we put right here? X. Okay? Those of you who are doing this right now, if you can help me out, who's got the answer? Remember, we're trying to do to 3 decimal places, and actually I'll just go ahead and jump in and do it with you. So menu 3.1, it's going to be when the tangent of 43 degrees, notice I'm in degrees right now, or radians right now. I can bypass that and not change it in degree mode. You're going to learn more and more about this as we go through. And just put degrees, and it's going to give me the right answer. It'll be comma x, and you should have gotten 39.166 feet. Did y'all get that as well? Okay, yes?
We still add 5.
Yes, we're still going to add 5 to this. So plus 5, it's going to be a weird answer like that, the way it shows it. Or you can type in, watch this, you can go here. You can take off this x equals stuff, right? And then you can just add 5 to it. You're going to get the same thing. So 44.165 or 166 would be my actual height of the tree. Nicely done. So remember, whatever we get here, which we got 39.166, we're going to add 5 so that our final height, like we said at the beginning, is going to become 44.166 feet. Questions? Okay, nicely done. Straightforward, right? That's just trig. For the most part, it looks like we'll use tangent possibly. Well, that's the only way we're going to do this, right? Watch this. That's a good question, actually. Will we ever... Okay, can you measure 42 feet? Yes, when we go outside, you're going to be able to measure 42 feet. Are you going to be climbing on that flagpole and trying to find the height of that? No. So you can't measure the flagpole. Okay? Could you get a long piece of tape and have someone standing on the flagpole, standing here, and be able to find this measure before you start? Yes or no? No, you can't do that either. So what trigonometric function most likely are you going to use when we get out there? Tangent. We're going to use tangent. Because we're trying to solve for O, and we know A. When you do these measurements, guys, I have them in measurements of 5 feet. You're going to do them in groups of 2, so you're going to pair up. So whenever you go to the flagpole, you're going to put that right next to the flagpole, go to the ground, and then kind of do this thing with it. You with me? So that's 10 feet. Here's so on and so forth. And that's how I want you to measure it very, very accurately, okay? Let me show you real quick. I know I can't record this on the video per se, but if you go to your app, go ahead and grab your phones out, please. I want you to go to the Compass app. So the Compass app, when you pull it up, it looks like this. Okay? What you can do, hold up just a bit. I will do it this way. I have an idea. Okay. So continuing with the video, what we're going to do is I'm going to show you how to use this Compass app. Alright, so go to the Compass app, wherever it is, find it out. Look for the Compass app, and when you open it up, it looks something like this. Okay? And what I want you to do is just swipe to the right, and you get something that looks like this. Now, when I horizontally move this app, my goal, okay, so watch, you see how it's all jacked, and I can reset it, jacked, and I can reset it, okay? So right here, I'm trying to reset it to where I can find 0 degrees. So let's say that the pole is way over there, and you're trying to figure out what angle it is to the tip of the pole. So you're going to stand like right here, one person's going to be here, and the other one's going to be here watching this number. So don't do this and be like, oh, what's the number? And then you jack it up. So you're going to be here, standing with your phone, and try to level it nice and pretty. There's 0, that's level. Someone's going to be here watching your screen, and from your eye right here, you're going to try to tilt your phone until you get to the top of the flagpole. And that person's going to read whatever that angle is. You see, this is like negative 34. There are negative angles when you're going up. The angles of elevation is going to be what? Positive 34. You understand? So this is going to tell you how many degrees is your phone going up in order to get the one that we did on this example problem as far as, we highlighted it nice and green, right here. You're using your phone to get that angle of elevation. Any questions before I continue? Yeah.
How could it get like it to pop up?
Yeah, neither of mine's in the measure app.
Oh, okay, so if it's not in the Compass, thank you for that. It's in the Measure app. So those of you who update your phones, obviously I'm not one, but those of you who update your phones, it's in the Measure app. That's where they put the compass. Thank you for that. We good? Any questions? Because I want you to know how to do this before we get out there. I don't want you lost out there, okay? Okay. So let's now move on to the next one. Okay, we're going to move on to, that was using a right triangle. Now you answer this question for me real quick, please. Just for a little bit. Is this a special right triangle setup or a non-special right triangle setup? What did we just do? One of the two we did. We did either a special right or a non-special right. Which of the two was it?
Non-special.
It was a non-special. Because special right triangles are only with what angles? 45, 45, 90 or 30, 60, 90. Okay? You're not going to have that depending on where you stand as far as for that flagpole. You with me? Alright. So, some of you are going to have different measurements. You figure out how far from the flagpole you're going to walk. Some of you may walk 10 feet. Some of you may walk further. This is very important. Those of you using the app, keep it under 60 degrees. Don't go past 60. In other words, if you're past 60, you're too close to that flagpole. Move back. You with me? And then you should get a good distance. Are we good? Alright, so now let's go to the second problem. Alright, so this person wants to determine the height of the Jumbotron in the arena. However, there's a stage in the middle of the floor, so he cannot get directly underneath the Jumbotron. Okay, this is similar to the other problem that we're doing today. You can't get close to it like you could on the first one. You're going to be far away all the time. Alright, so he cannot get directly underneath it. So from where he stands, he measures the angle of elevation to be 30 degrees. Okay, so this angle of elevation is 30 degrees. Are y'all with me? Okay, and this right here is the top of the Jumbotron. So think of there's the Jumbotron or whatever. Okay, so there's your screen. There's your other screens. Oh, that's pretty good. That's not bad. All right, so so it says he walks 20 feet closer and he measures the angle of elevation, and now it's 36. So when he walks closer, how many feet did he walk? 20. He's now going to take another angle of elevation. Again, remember that angle of elevation, let me highlight it. It's this right here coming from the horizontal. And this one's going to be 36 degrees. You with me? Alright, so 20 feet that he walked, just so that you can visually wrap your brain around it, it's the same as that length right there. Alright, Connor's line of sight is 6 feet from the ground. That means his eyeball is 6 feet. Are we good? And then it says, how far is the Jumbotron from the ground? So we're trying to determine how high is this going to be from the ground. A lot going on here, right? This one is the question. That other one just warmed you up. Are we good? All right. So what do you suggest as far as our approach? First of all, is it similar to the other one in this respect? If we solve for this height here of the triangle, and we just add 6, we have our answer. Yes or no?
Yes.
Yeah. So the goal, with that in mind, is that we're going to try to find this height somehow. You with me? And the only piece that we have, the only piece or pieces, are these right here. You got to take these very, very carefully and very exact, okay? So the only piece is, we have this, we're going to talk about it here in just a bit, and then the other one is 20 feet. Can someone tell me, please, what is this angle from this that we just did? What is that going to be? 144. Guys, how did you get 144? Because it didn't say 144 anywhere in the problem. You subtract it from 180 because you know that this angle right here, okay, is going to be supplementary to 36. So that's 180. Ask me questions if you have them, okay? So 144. My goal is to get that height. Who can tell me what we should do?
You should add 30 and 144 together.
Okay, hold on just a minute. Let me catch up. So he added 144 and 30 to get 174. So now I know all three angles of what's inside. Do you agree? I have all my three angles, and I have one of the sides. Okay? What do I do? What's next?
Put a 90 degrees.
There you go. There you go. Nicely done, guys. I'm looking for this, correct? I'm going to use law of sines to find that possibly. You with me? Could I use, okay, let's set up the law of sines. What over what? Start me out. What do you want to put over the sine of what angle? Okay, so 20 over the sine of 6 degrees. Guys, this is some nice real world application, by the way. It really is equal to what?
X over sine of 30.
X over the sine of 30 degrees. Nice. And look, I'm going to color coordinate it for you. This piece that we're looking for, that's X. Let's go to the calculator real quick, okay? I'm going to ask for your help because you wrote that down on your paper. Menu 3-1. What did y'all do again? 20 over sine of 6. I am in radian mode, so I'm going to make sure I put degree. If you have it in degree mode, you don't have to keep pressing degree. And it's X over, what was it? Sine of 30. So sine of 30, I gotta put degrees again. And it'll be comma X. So that length, how many decimal places should I put? 6, because I'm not done with the problem. I'm not done with the problem. So let's go ahead and put 6 decimal places on the picture, okay? So 6 decimal places. This X value is going to be 95.667722 feet. Okay. What do I do next? I don't need to do law of sines anymore, believe it or not. My goal was to get this piece because now I have 30, 144, 6, 20, and then this 95.667722. What I could do now is I could do just a regular right triangle of what I did on the first problem right here. Are you with me? Oh, yeah, I'm sorry. So I have this triangle of the gray triangle that I just shaded. And from this gray triangle, it is a right triangle. I know what piece of this triangle do I know? It's not 30, 60, 90, not on this one.
No, 36.
Oh, my bad. 36 degrees, yes, I know 36. And what else do I know?
You know that one side of
The hypotenuse, the H. The H is 95.667722 feet. You see what we're doing now?
But you know the other angle too.
So we know the other angle. What would this angle be?
54 degrees.
54, because we know these two add up to, or all three add up to 180, yeah. So do I have to do law of sines with right triangles? No. I could just use SOHCAHTOA and I'm done. You with me? So if they're right triangles, you don't have to do law of sines. Law of sines is for non-right triangles. Law of cosines is for non-right triangles. But if you have right, use SOHCAHTOA all day.
You would use the sine of 36 degrees.
There you go. Sine of 36. Remember, from SOHCAHTOA, sine is opposite over hypotenuse. Opposite is what we're looking for. That's the height. Hypotenuse is what we found from that other piece. So we're going to say sine of 36 is equal to x over 95.667722. Let's go ahead and put that in our calculator and see what we get. All right. So we have, again, menu solve feature, menu 3-1. And we're going to have the the sine of 36 degrees is equal to the height opposite over what we got of 95.667722. Oops, that's not a 7. And we're going to say comma x. Why is this the wrong answer?
Because you still have to add
Because I still have to add 6. Nicely done. Because your line of sight is higher. So we would end up getting an answer of the height, we could just put h is 62.232, because I only need 3 decimal places in my final one, feet. Are we good, guys? Now listen. All we did was this part of the stuff. So the only thing that you moved was here. Were you anywhere close to the Jumbotron? No, you never ever got underneath the Jumbotron. So when we go outside and we measure that part of the auditorium that I said that we were going to look at, when we measure that, I think I deleted it, you can't get close to it. Okay? You can't get close to it like you could with the flagpole. You must stay a certain distance away. But the same tools are going to be used. Are we good? Yes?
So if you were to use law of sine to find that, would it work?
It would still work, yeah.
It's just more work.
To me, it's a lot more work. You know what I mean? Like in the end, when you're doing PSAT or SAT and ACT tests and stuff, and that's on there, you don't want to do that unnecessary work. Okay? Any questions? All right. So what do you think is really important for you when you go outside? And you're going to pair up here in just a bit. What must you be careful, do you think, before we go outside, with all these measurements and whatnot that we do? What do you think? The angle cannot be bigger than 60. Yeah, that's number 1. What's another one?
Watch out for cars.
Watch out for cars. I'll do that. Okay. But what else? What would you say? Say again? Knowing the distance away from the flagpole, right? The distances that you measure have to be very, very close, right? Don't just take approximate distances. What else?
Not shaking your phone.
Not shaking your phone, making sure that it's nice and someone hasn't said it yet. There's something else that we have to measure when we go out there that was just given to us.
How tall it is?
How tall from your eyeball to the floor. Okay? You have to know how tall you are as well. You agree? Okay. Alright, so you may put your, let me stop the video.